Okay, this is a really short video on algebraic proofs. So to do algebraic proofs is pretty straightforward because they give you an answer. So you have an equation or you have a problem and they've given you an answer. You've just got to prove it by basically just doing the workings for them. So this is all about showing the workings to problems. So if we have a look at these ones, these are all fraction problems, okay? So the first one, we got 3x over 3 plus 2x minus 1 over 4 plus 5x plus 2 over 5 equals 50x plus 3 over 20. So to prove this is correct, we've just got to do the workings of the fraction. So add in fractions, something you need to do your prior knowledge on. So you need to know to add fractions, the denominator needs to be the same. So currently the denominators are 3, 4 and 5. So you need to change them, manipulate the fractions, make them equivalent so the denominators are all the same. So you think of the multiples of 3, 4 and 5, so what time they're times tables, and what number goes into all three. So the number that's in all three times table you could choose is 60. There's other ones, but I'm just going to go with 60. And then we want to manipulate the fractions so they're equivalent and over 60 instead. So this first fraction, what would I need to multiply all by to get it over 60? I would need to multiply that by 20. With the next one, I would need to multiply that by 15, and the next one I would need to multiply it by 12 to get it over 60, because 3 times 20 is 60, 4 times 15 is 60, and 5 times 12 is 60. So now you want to multiply the numerator, so you want to multiply the top by those numbers as well. So I'm going to do 3x times 20, so that's 60x. I'm going to do 2x minus 1 times 15. So 2x times 15 is 30x, and minus 1 times 15 is minus 15. So don't forget to multiply that second number. If you want to put them in brackets to make it easier for you to expand the bracket, that's absolutely fine. Next one, 5x plus 2 times 12. So 5x times 12 is 60x, and 2 times 12 is 24. So these are all add-in, so this is a pretty straightforward one. So now we've got... we just need to add the tops now, so I'm going to write them in a straight line. So we've got the top numbers as 60x, we're adding 30x minus 15, careful when you come to negatives, we're adding 60x plus 24, and because the denominators are the same, we can write them all over 60. So we can work out the top now. So if we collect all of our x's, if I've got 60x plus 30x plus 60x, that's 150x. And I've got minus 15, add 24, so that's positive 9, and that's over 60. We're very close to it being this answer. So to get from this to this, you would literally just divide by all of them by 3. So if I was to divide 150 by 3, I would get 50x. If I was to divide 9 by 3, I would get positive 3. And 60 divided by 3 is 20. And that is our proof. We've got our answer. I'm going to show you one more, and it's going to be an exam paper. Let me see if I can choose one with negatives for you. So this one, we've got to prove that 2x over 7 take away x minus 3 over 2 plus 3x plus 2 over 21 is 67 minus 3x over 42. So exactly the same thing, you want to choose a denominator that is in all of their times tables. You can jump straight to 42 if you wanted to in their question. So we can jump straight to 42. So I want to change this fraction so it's over 42. I want to change the next fraction so it's over 42, and the next one so it's over 42. So with the first fraction, how do I go from 7 to 42? I would times it by 6. With the next one, how do I go from 2 to 42? I would times it by 21. And how do I go from 21 to 42? I would times it by 2. So you now want to times the numerator by that again, like we did in the first question. So 6 times 2 is 12x. And we're subtracting x minus 3 times 21. So we want to do x times 21 to get 21x. And minus 3 times 21, that will stay as a, I should have maybe zoomed in, minus 63. We're adding 3x times 2, so that is 6x, and 2 times 2, so that is 4. And again, we can collate to the top, so the bottom will stay over 42 because they're all 42. And we'll just write these in a line now. So we've got 12x, we're subtracting 21x, and we're subtracting minus 63. So that's going to become a positive 63. Because when you subtract minus 63, you're actually adding 63. Then we're adding 6x, and we're adding positive 4. So we're adding 4. And if we were to collect our x's, so we've got 12, we've got take away 21x, and then we've got add 6x. So we've got 12 minus 21, add 6 gives me minus 3x. And then our numbers, we got 63, add 4 to give me positive 67, and it's over 42. So it doesn't quite look like the top because they've got these two the other way around. So you can just flip them over now. So if I was to flip these around, I would go 67 minus 3x. They don't normally like a minus at the front, that's why they've done that. Over 42. So algebraic proofs, really straightforward. You just got to prove the answer is correct by showing your workings. You'll be able to tell if you've gone wrong because your answer won't be this. So you can work backwards and figure out where you've gone wrong. Maybe it might just be two negatives next to each other. So double check, go back over your work.